Yeah, let's go ahead and start the recording. Folks, you can still see my screen. Everything's good?
Yep.
Okay, cool. So, folks, we had the lab, right? And again, we're diving into the lab about RIP being a distance vector protocol, meaning it goes based on which route has the less hops, right, to get to the destination, right? And of course, we understand that RIP, one of its limitations is that it only can go up to 15 hops. Beyond that, traffic is being dropped. Another thing that I wanted to have a short lab tonight and make you guys aware of is, version mismatch, right? And how that would cause issues and how that's going to make sense for you guys whenever, in the future, whenever we're talking about eGRIP, different versions, or we're talking about OSPF, different versions, okay? And why it's so important to make sure that both sides of your link, right, whether it be two routers, two firewalls, two multi-layer switches, that they're talking on the same version of protocol, okay? So you see our network, right? We understand that RIP is, classless, and it's, it doesn't really worry about subnet mask, but, version 2, RIP version 2 made some improvements, right? So that it can, it can do that. But looking at our network, right, we're using a 10/8, but we segmented it across this network that we have. So we have a 10.17.1.0/24 on the left under R1, and we have a 10.17.2.0/24 on the right. And our WAN circuit is a 10.10.1.0/30, right? So only two IP host addresses are available. So that's perfect, okay? And so, right, and for our network, right, let's say, back to what me and Jose was talking about, let's say this is our data center, and we want these two routers to talk that are on the same campus. So let's go ahead and let's do RIP between them, okay? And so we went ahead, and for some odd reason, right, we're not getting routes on how to get to 10.17.1.0 on R2 from R1, right? And why is that, right? So let's go ahead and let's hop in these routers. I got these up. Pull up a whole new, fresh window. And folks, at any point, during the breakdown, if I'm going too fast, not explaining it good, please stop me and I'll go ahead and I'll go more in detail. So as you guys know, our test PCs, PC5 and PC6, those are our test PCs, okay? So just to level set with you, let's look at the IP addresses. This PC, which represents PC5, has IP address of 10.17.1.26, and PC6 has an IP of 10.17.2.26 from their routers. Okay, and let me do this a little bit. Give me 1 second. Let's change what that looks like. PC5. There we go. Yeah, let's change that. Yeah. There we go. PC6. Just so you guys can track, okay? So we have, we have our two test PCs. PC5 is going to be our source. PC6 is going to be our destination. It's going to be vice versa whenever we're testing our traffic, okay? So just like the scenario I went ahead and explained, right? R2, it doesn't learn about that network that's behind that LAN that's behind R1. Why is that, right? And the goal of tonight's lab is to show you the importance of understanding, making sure two routers are talking on the same version, okay? So again, we're using RIP, and let's check what version R2 is running on, and then let's check what version router 1 is running on, okay? So let's go ahead and run that. Oh, Jesus, don't do that. Let's go ahead and do this, put this in the little corner. Boom. All right. First, as always, we hop into the switch before we check anything. Let's check that running config. We can see, of course, the information about our routing protocol that we're running there within that. Okay, perfect. So from what we were looking for, it tells us exactly what we're looking for. So we're running RIP, on this router, so we confirm that, and we're running version 2. Okay. Again, our issue was, we can't reach 10.17.1.0. Let's go ahead and confirm that on our routing information base, or our routing table. Okay. So as you can see, we don't have any routes in our table that are sourced with the letter R, right? On this side, we don't see that right here. Why is that, right? That means, if whenever we do verify, we go to router 1, we don't see, we may see RIP running, but there may be, an issue as far as we're running a different version. So they haven't even exchanged anything. They haven't exchanged any routes, nothing, because it may be that version mismatch. And we just verified through our running config, we're running version 2, right? And of course, through our routing information base, or our routing table, we don't see, right? We don't see anything here, for that network, right? And let's take it a step further. Just like I would, me and James and a lot of you guys, we did in the past. Let's also check layer 1 and layer 2 and make sure we have a connection. Okay, so we're in a 10.10.1.0/30 network, right? Okay, and we have the host address of 10.10.1.2, right? We have that on gigabit 0/0. So let's go ahead and confirm that. Let's do a show IP interface brief. Okay, perfect. So we confirm we have a 10.10.1.2 on R2 on a gigabit 0/0 interface. All right, and let's do a show IP arc. Let's make sure that we're learning about, the other side on this router, right? Perfect. So we have our LAN interface, we have our WAN interface, right? Let's go ahead and generate some pings, see if we can populate this ARP table. Let's try to ping 10.10.1.1. Cool. Now let's check our ARP table now that we populated some traffic. Perfect. Cool. Perfect. So we can reach R1, right? We have its MAC address, right? Let's see if we can reach 10.17.1.26, right? We know we can't, but let's go ahead and just verify, right? Because we're engineers and we don't go based off of just what we see. So 10.17.1.26. Nothing. 100% loss, right? Let's do it again just for good measure, right? Make sure we're not crazy, right? Nothing, right? Why is that, right? This router doesn't know how to build that packet, create that packet, and it doesn't know what interface to shoot it out of, right? I already don't have a quad 0 route identified, so it's I have to go based off of what I have using dynamic routing, right? So let's go ahead and troubleshoot. Let's see what's going on, what we have set on the other router. So we can reach the other router. Let's see what's going on, because we already established we're doing dynamic routing. We're doing RIP. So let's see what's happening. Let's go ahead and get into router 1. Perfect. And again, just like me and James did in past labs, first thing we do when we jump into a device, whether it be a multi-layer switch, router, firewall, whatever, we're going to check that config before we do anything. It should tell us everything that we need to know. Okay, you see our interfaces. All right, you see our interfaces configured here. We have our WAN interface, right? That we confirmed we were able to do a ping on, and we have our LAN interface, right? Which is in this scenario, right? We're sourcing from PC6 and going to PC5. So we need to, make sure that, hey, 10.17.1 something exists. So it does, there is a IP address configured on its, its LAN interface. So that's golden. That's golden. Let's make sure it's running RIP. Okay, it's running RIP, but something is different. Let's go ahead and do a side by side. Let's do a show run again. And folks, feel free to unmute yourself. I want somebody to tell me what they see different between the configuration of RIP on these routers.
The version of RIP.
Perfect. Exactly. Right. And so, how that's important, right, is if they're running two versions, right? If you ever do a packet capture, you know I love packet capture. And of course, Claude's here as well. So he'll tell you, he'll do debugs. And I even love debugs even more because they even tell you what the router's doing. So router 1 and router 2 is probably communicating about RIP, but they can't agree on anything, right? Because it's, you know, router 1 is, you know, for example, to keep it simple, is talking a language that router 2 doesn't understand, and vice versa, right? So we're running two different versions. They're not sharing, you know, any routes or anything like that. So, Patrick, how would we resolve this?
David, can I ask you something?
Absolutely.
So this is about like more to your statement about they're talking a language that they don't understand. And so one point that I remember reading about is, and you mentioned it, how one is classless and one is fixated on the classes. And I would say,
absolutely,
getting it right, I think RIP1 is fixated on the class and RIP2 is classless. And so
absolutely,
I'm trying to understand, is there, with that knowledge, is there a way to kind of, you know, short of changing and getting them on the same version, say for instance, could you kind of partially fix it? I don't know why this would, you know, this wouldn't be a practical thing to do, but I'm wondering, just for the sake of how broken it is, if it's possible to tweak, like, because right now, if we're using that the 10 range IP address, wouldn't that be class A, right? But we've changed class A to kind of have a class C subnet mask, right? That's what we're doing,
right
on router RIP.
Right.
So could you? Is it possible to, if we would put it in a respective class? I don't know which one we'd have to do that first on. Like if we had them on the same class, like we still use 10, but maybe it would be like a /8 instead of the /24. Would that fix it, or is that just
guess what? We're both engineers, right?
Okay.
So we're about to test it. We're about to test it. We're both engineers. So now, hey, pulling you in, James. Now you're the other engineer, right? But let's think about what you said, because you said some key things, right? Version 1, it's worried about class. Version 2, it's worried about classless. And Claude will go ahead and keep us honest. He's over there playing a fly on the wall. I know he'll unmute himself in a little bit. He loves layer 3. So, right? So, James, you said something perfect. Version 1, it's worried about class. Version 2, it's not, right? So let's go ahead, right? On both of them, let's attempt to configure the network command under the router configuration. Let's go ahead and configure that for the specific router, and let's see the difference. Let's see if there's any change within the running config after we do that, okay?
Okay.
Let's go ahead and do that. So, Patrick, if I'm understanding you correctly, you want me to specifically identify the networks based on their, not Patrick, James. You want me to specifically identify it via the subnet mask, correct?
Yeah, their respective subnet masks. Like I guess what I'm saying is we're using, so these 10 networks are typically class A, I believe. So they would use a class, they would use a /8, right? So so since the router 2 is already on version 2, then it should recognize that with no problem. But now since I mean, if we change the IP on router 1, like if we leave it as is, but we just made it like a class, a C class. I'm sorry, I'm saying the right thing. A /8, or give it a class A subnet mask, and I'm wondering if that would fix it. And it's not even practical. It's not even what we should do. I understand that we should really just get them on the same versions, but I guess more for curiosity, I'm wondering if that's the reason behind why they're not, you know, speaking the same language. When you said that, you know, one is talking one language and the other one doesn't recognize, I'm wondering if that's the reason behind it all. But you know, James, it's all good. It's all good. And again, don't worry about best practice. We'll worry about that later, right?
we're engineers, right? It's our job to play Ghostbusters and piecemeal stuff together, right? Everything's not going to be perfect as we see it in the book. Okay, so remember that. So don't worry about best practices. Let's say this is a situation where me and you are working, I don't know, we're working for a huge company, right? It's critical. We need to go ahead and get this routing thing figured out. So we would, just like scientists, we would go ahead and create a theory and test it. So this is your theory. You want to go ahead and implement that and see what's the difference, right?
Right.
If it fails, hey, we're going to go ahead and go back to creating a theory based on the 7-step scientific method. If it works, perfect. We're done. We can go ahead and give a report, and as engineers or scientists or what have you, we come back with something better, right? When we have some downtime. Okay.
Right.
So let's go ahead and try that. So router 1, we have the 2 networks. We have the /30 and we have the /24. So let's go ahead and do that. Right. We're still keeping the same versions, just like James said. So 10.10.1.0. Okay. That works. And we're going to do the LAN. So 10.17.1.0. 255.255.255.0. Why did that fail?
Oh, right away.
Anybody?
I'm assuming because it's RIP, it knows it's insider.
Come on, Patrick, keep talking.
So it is saying this is incorrect because it doesn't fit in the Class A subnet range.
Exactly what James just said. Perfect job, Patrick. Exactly what James said. Version 1 is worried about class. It already has it predefined in the background. 10 networks /8. 172.16, it's a /16. 192.168, Class C. You can't define the subnet. So it's always going to be a 10.0.0.0 in the network. We can't define the subnet. But let's go ahead and try to at least define, right, the network, right? We can at least say, hey, just like James was saying, let's identify the specific networks, 10.10.1.0, and let's identify network 10.17.1.0. Maybe that'll help, and maybe we'll have a difference. So let's go ahead and try that. We configured it. Perfect. So now let's go ahead and check the running config, see if there's any difference. Any difference? Any difference?
Not that I see.
So this is exactly what Patrick just laid out, guys. Right? Patrick and James just laid out. RIP version 1 is worried about class. Right? It's already pre-configured in the background. Hey, dude, anything with a 10 network, bro, it's a /8. I don't need you to tell me anything more specific. Just say, whatever you type in has a 10 network or a 192 network or a 172.16 network. I don't care how specific you get. We're just going to keep it as such. Make sense?
Yep.
Okay. So let's try to do the same thing, right? Just for testing purposes on R2, which is running version 2. And let's see if there's any difference, right? To test James' theory. So we're going to do the same thing. Network 10.10.1.0. Okay. And let's also test doing it with the subnet mask.
I think it's set up for RIP right now. It's RIP.
Yep, it's still set up for RIP, but I wanted to test James' theory, right?
Oh,
so
yeah.
No, it's all good. It's all good. It's all good. Good catch. So of course the subnet also didn't work for version 2, because again, it's like Patrick said. Patrick brought a good point. It's still RIP. So it's still not going to work. It's still worried about that in the background. So let's go ahead and try to see, right? If we say 10.17.2.0 and see if there's any difference, right, in version 2.
Well, we're running version 1 on router 2 right now.
Look, we're running version 2.
Oh, we are? I saw the command there. It said RIP. Oh, okay.
It's all good. Okay. What do we see?
Session version 2 network 10.
Any difference?
No change.
No change.
No change, right? No change, right? So
question. If RIP version 2 is classless, wouldn't it require the subnet mask like OSPF does and EIGRP does?
Perfect. Danny, you asked something perfect, right? And I know Claude's going to jump in one of these times. He's playing on his BlackBerry right now. But let's talk about this, right? So even though R2, right, it's running RIP version 2, an enhanced version of version 1, right? This doesn't mean, right, on the front end, on stage, that the route is you're going to be able to identify subnet mask. Exactly what James said, with a little bit of tweaking, it works exactly how James said, but in the background. Okay, version 1 is worried about class. Version 2 is classless, right? But unfortunately, right, you're still, as far as the configuration standpoint, you still can't specify the specific subnets. Can't specify the specific subnet. It's still overall going to be about class for RIP, which is why it's so inefficient. So let's say me, James, Patrick, and Daniel being the engineers, we're sitting on a round table. We got a whole bunch of donuts, and we done went through the whole thing of donuts and coffee because we're stressing out of why this router. I mean, I didn't had 5 jelly donuts, so I'm already fat, right? So we done wasted almost a whole workday trying to figure out why we can't program specific, networks and subnets on these 2 routers, because we need to get them up and running. We've been troubleshooting for almost 8 or 9 hours now. This is the limitation of RIP. This is the limitation. Okay. So, James, going back to your question, as far as can we piecemeal together maybe a solution, even though they're running 2 versions? Okay. My answer to you is no. We're going to have to scale up the version of RIP on here. Okay. And also what Claude said in the past, right? What Claude said in our last session, as far as RIP. RIP has slow convergence. We can go ahead and change this to version 2 on router 1. It doesn't mean immediately it's going to go ahead and start communicating. Okay? That makes sense?
Yes, thank you for entertaining my questions. I appreciate it.
Nah, no problem. No problem. So let's go ahead and make that change.
Also, since you're talking about RIP, how would RIP NG work if you're doing IP version 6?
Yeah, so it'll go ahead and just funnel IP version 6 the same way, but it's not going to worry about subnets. It's going to be able to handle version 6.
Now, to me, if you work on a job assignment, they're using RIP, I would try to convince them to move to OSPF or EIGRP.
100%.
Preferably
I'm with you.
Preferably OSPF, because OSPF, you don't have to use network statements. Just type it, go to interface command, and just type in, make the port a member of OSPF.
Mm-hmm. Definitely. So let's go ahead and check to see if we see any changes in our, and again, guys, I'm going to use these big terms because I want you guys to be great engineers, and when you walk into a room, you'll be able to understand these terms. So let's check the routing information base, aka the routing table, on each of the routers, okay? And let's see if we see any updates yet. Cool. So look here. So now both of our routers are talking. Okay. Know about the specific subnets. So Patrick, so now that we went ahead and implemented version 2 and went with your theory, right? Again, it's me, you, James, and Daniel in the round table trying to troubleshoot this for our network. Now that we changed to version 2 and we see these networks, should PC6 be able to communicate with PC5 now?
Yeah, it should.
Okay. All right. So with that theory, let's go ahead and attempt to see if that's the case.
There's no way. Yeah.
Versa. Perfect. We got bi-directional traffic going both ways. Everything's working. We're smooth. We're smooth. So that was a fix in our sense. But again, another limitation of RIP, which is why they, of course, again, with what Daniel, to agree with what Daniel said, RIP has too much inefficiencies to be deployed in a production network at this point in time, right? But it's important to learn about RIP, it being a distance vector protocol, because you'll walk into an environment, maybe they're running another distance vector protocol, right? So you have to understand how it works, why the versions have to be the same, right? For example, OSPF, they have different versions. So we have to make sure that they match or what have you, and they're talking the same language based on, back to what James was saying, the point that he brought up. So very important to go ahead and get in your packet tracer, your physical lab, what have you, and practice this and understand the intricacies so that whenever you do jump to these higher protocols, whether it be link state or distance vector, it'll go ahead and make sense. Okay? Any questions, folks?
How do you remember? I was just gonna ask, how do you remember, like, because I always get confused on like OSPF, is it link state or distance? Like, I guess I just have to, practice and study more. But is there any tip you have or something that that you can remember easily? Okay, I know RIP is a distance vector and stuff. Like, how do you go about it as far as memorization wise?
No, good question. So for me, me looking at it, a lot of times, right? And labbing it up a lot. I know, for example, right, the defining factor, right? Just like we talked about with STP, the defining factor is link state, right? And that's the cost, right? That we're looking at for OSPF. I know, of course, looking at it for a long period of time, that distance vector, the dynamic protocols that fall under that is egrip and RIP. Okay, so again, for me, it's only with time, right? And then of course I piecemealed stuff together in my brain to say, okay, I've seen this long enough, and I know OSPF is a link state and has to do with that, right? And egrip and RIP, distance vector has to do with that, right? And I labbed it so many times. So for me, again, it's about labbing and seeing it enough to say, all right, I already got it in my brain and saw, hey, this is link state, this is vector. And if there's any other dynamic protocols, dynamic routing protocols like ISIS or BGP, I can understand the difference of the two, right? Maybe James, Claude, Mike, Christian, Daniel, what have you, or Jose probably can answer the question a little bit differently.
Yeah, I can answer it a little bit different. What I usually like to look at is the term link and distance. You know what I'm saying? Link really refers to the cost, which is similar to what you said, David. You know what I'm saying? But in most cases, like the more higher end IGPs and stuff like that, they use link state. So I look at link, and that's the cost, and then distance is the hop count. So most of the lower end IGPs use hop count. But the only real exception you have for that is EIGRP, which is advanced distance vector, but that's only a Cisco thing. So if you're not in the Cisco world primarily, you probably won't see it.
Okay, cool.
If that makes sense.
Yeah, it does. And I just grabbed something from David quickly from his reasoning as well. So when he said like egrip and RIP, in my mind, I like to remember things like that, like grip, or
Yep.
Okay, that would help me, at least for me, because even the same thing with like encryption methods when I'm like trying to remember AES or RCA.
AES. Yep. And cha. Yep.
So that's kind of how I remember things in my mind.
Nice. Love it.
Cool.
Love it.
My mind works the same
Mike,
way. I didn't even realize that eGrip one. I'm gonna take that one too, David.
Hey, listen, that's all Patrick. You know, listen, I still haven't beat Super Mario Brothers, so
Thank you,
I
Patrick.
need to keep stuff simple and easy. Okay.
Yeah.
So good stuff, Mike. Thanks again for that breakdown.
Thank you.
Any other questions, folks, about tonight?
Nah, I'm good. I'm good. Good to hear from
All
everyone.
good.
Mm-hmm.
Good stuff. Yeah. We got a full house tonight. So guys, our next session, hey, we're still staying with distance vector, but like Mike said, we're gonna go a little bit advanced. So I'm gonna give you guys 2 weeks. Go ahead and study up or what have you. And even if you don't have time to study up, it's all good, baby. We're gonna go ahead and have that lab about eGrip. But again, we're going with the fundamentals. We're gonna touch on the fundamentals. Claude is probably gonna have a field day with that. So Claude's probably gonna tell me to shut up and let him talk. So lab up, look at it if you do have time, or what have you. And bro, we're gonna have fun with this routing protocols. Again, we're going through all of this so that we can go ahead and jump into those transport services that you guys probably gonna work on in the future, which is like James said, you know, those type of VPN tunnels or GRE tunnels, what have you, or you know, or a lot of these transport technologies like, what's another one? Can't think of none right now. I can't even, it's been a long day. But, you know, it's a DMVPN, right? That's another thing. Or multicast routing, right? A lot of the things that we're going over right now are fundamentals before we jump into that, okay? Reverse path forwarding, okay? So these are just a couple of things that you need to, before you jump to that, which are used in production environments, you have to understand how, of course, one, layer 2 works, and of course, how layer 3 works, most importantly, okay? But on that note, I'll go ahead and stop it. Guys, thanks so much. And again, if you got any questions or anything, feel free to reach out. So I'll see you guys in 2 weeks.
All right. Thank you, man. Thank you.
Thank you.
Later,
All
folks.
right. Congrats,
Have a good one,
everybody.
everyone.
Congrats, everybody who leveling up out here. I'm glad to see it, man. Peace.
Oh yeah, most
Yes,
def
sir.
people. Most
Thank
def people. Later.
Good
Likewise.
seeing y'all. Bye-bye.